analyze the post-projection implementation impacts of wetland restoration on the carbon cycle. Research then informs policy, which builds a framework for streamlining legal proceedings and addressing social issues when working on restoring water resources. Katrina's project addresses this part of the process. She will guide us through the federal regulations that influence restoration practices, as well as the process stakeholders can follow for project implementation. Research and policy can then be used to guide cohesive planning efforts across different agencies, nonprofits, and private landowners in their land management and restoration efforts. Katie dives into this phase of the restoration planning as she's developing a watershed-wide prioritization analysis for restoration opportunities across San Juan County in southwestern Colorado. Finally, this all coalesces into the implementation of individual restoration projects that benefit wildlife, humans, and all other biota in the face of climate change. My project has been focusing on this phase. I've been focusing on implementing and studying the impacts of low-tech process-based wetland restoration methods on an ecosystem's ability to support healthy wildlife, vegetation, and cattle grazing. We hope you enjoy our journey as we explore the broad strokes and fine details of wetland restoration. With that, I'll pass it off to Etinosa.
Hi, everyone. Hello. Okay. All right. My name is Etinosa Igunbor. And for my project, I actually look at the geospatial modeling of soil organic carbon in a restored wet meadows or a sagebrush ecosystem. So by the picture by your right, what do you see? People call it black carbon. Some people call it air pollution. But however, it all accumulates into what we call the greenhouse gases that has the effect in what we know as the climate change. Now, from Africa, you experience flooding down to the drought in South Asia, to the wildfire in Canada. We cannot just undermine the fact that climate change is real and it's here to stay. Now, the more population growth we have, the more carbon emission we see, and also the more climate change impact. And so what should be the way forward? Now, by your right, okay, by my left, yeah. So this was actually a graph by NOAA last year to show how there's been a growth in the atmospheric carbon dioxide equivalent. And you can see that 60 years span, there's been an increase, not one single reduction of the amount of carbon emissions we have in our ecosystem. And currently last year, we were about 419 parts per million of CO2 emitted, and that was about 1.3% increase from the previous year. So, but however, GRISCOM proposed what we call nature climate solution, or rather nature-based solution. And it's a local means of restoring degraded area that can help to mitigate those amount of emissions down to about 37%, all between 15 years. So just an intro on what we call the nature climate solution. They are local actions that helps to protect or rather manage degraded land area. And they have just two major functions. One is that they help to store carbon back into the soil ecosystem, and they also help to reduce greenhouse gas emission. You know, this nature climate solution has been done in a lot of ecosystem like coastal habitation, wetland, agricultural land, and forested area. And so, yeah, so just to give you an idea of what is the impact of wetland restoration, or rather wetland restoration as a nature climate solution. We can see this one of our sites, Wolf Creek, actually began restoration in 2012. And we can see just between 4 years, you can see the increase in plant cover density. And so we are proposing that nature wetland restoration would definitely increase plant productivity, or rather plant cover, which will increase the amount of plant biomass within the soil ecosystem, and therefore lead to an increase in soil organic carbon. And so just an introduction of between why we choose this particular research. We understand that there's need for us to take this carbon in the atmosphere and back into the soil, which can help us mitigate climate change. But however, in terms of measuring soil carbon, it has always been through a local method of going to the field, collecting your sample and analyzing it. And this method, they are time consuming and laborious, and they have they lack the special limitations. And so we were thinking of, can we propose a more effective way of actually monitoring carbon accumulation in a restored wetland ecosystem? And so what we did first was to see what similar study has been done about the relationship between these remote sensing indices and soil organic carbon. And you can see Otwood and Slater have done study on trying to look at the relationship between soil organic carbon and NDVI in some landscape. But however, when it comes to wetland, there's not been much study that's been done. And so we are laying the background for further study of it. And so we have just two major research goals. One was to understand what is the feasibility of using remote sensing to actually predict soil organic carbon accumulation in a restored wetland and sagebrush ecosystem. And two, can we develop a predictive model that can help us predict carbon accumulation in this wetland in the next 10 or 15 years? And so just to give you an intro of our site, so I actually work on two sites, Sapinero Mesa and Wolf Creek. They are both in the Upper Gunnison Valley. And the plant type is the wet meadows and the sagebrush. And one of the historical land use of this site was that there's been a lot of overgrazing over the past few years, and also tree construction. So for Sapinero, restoration actually began in the year 2017, and for Wolf Creek, it began in the year 2014. And so most of you might not, Sapinero Mesa, where it is. And this is the map of Gunnison, and this is where our site is. And one unique thing about Gunnison is that the plant growing season is just 60 days. And so this have a great influence on how much soil carbon is accumulated. So our sample design and methodology. So this is our first site. This is Sapinero, and this is Wolf Creek. This line here is the wet meadows, and our surrounding is the sagebrush. So we took about 10 transits with 10 sample points at each, and that gives us like 100 sample points in each of the sites. Thereafter, we went to the field to collect our data, and we call our sample at soil depth 0 to 10. That's because for soil carbon, it's mostly at the topsoil. And so we thereafter calculated for organic matter bulk density, and we did our estimated soil organic carbon from this equation. So the total sample collected for Sapinero Mesa was 95, and while for Wolf Creek was 97. This was due to the fact that we had issues with water lock condition, and also the rocky nature of our sample point. And so for remote sensing indices, we chose 6 indices to work with, the NDVI, GNDVI, collaboration index, GSI, SAVI, and GLI. The NDVI, GNDVI, and SAVI, they are indices that mostly tell us well about how the health of a plant. And so we just draw that correlation that if a plant is healthy, then it's an indication of the organic matter content, which also have a correlation with soil carbon. And so we also understand that when it comes to soil organic carbon accumulation, there are other topographical data that also influence, which are the slope, the aspect, and elevation. So we took our remote sensing indices, we processed using Sentinel-2B, using the closest resolution, which is 10 meter spatial resolution. And we went over that to get the dam from the US national map of 10 meter resolution also. So the idea was that due to the fact that soil carbon accumulation is over time, so we wanted to see what best data, do we use a 5 years satellite data compared with the 3 years, or the sampling point or sampling data to see which of these 3 years post-restoration phase will give us the best prediction of soil organic carbon. And so just to give you an idea of what we did. So for soil organic carbon modeling, we went in 2 phases. Firstly, to model with just remote sensing indices alone, or to model, and also to model with remote sensing and topographical data variable. Thereafter, we did 4 machine learning principles, which are principal component analysis, stepwise regression, partial least square, and mixed-GAN computational vehicle. Further, we did a cross validation, and also we did get the best model accuracy. So this is what we call the principal component analysis. It just kind of tells you how your variable, what is the variability of your variable. And so you can see that for the 5 years, NDVI, SAVI, GLI, and NDVI, they are saying the same thing. And so if you want to strengthen your predictive model, you be careful to include variables that have similar or that are highly correlated. And so also the same similar thing for the 3 years mean satellite data and also the 1D satellite data. So just a summary of what we did. So we can see this is modeling with remote sensing data alone, and also modeling with remote sensing data and topographical data. And so in conclusion, this is just a summary that the mid-camp computational vehicle, that's the sampling day satellite data, gave us the best prediction with the highest R-square adjusted value, low RMSE value, and low MAE value. And when we also combine other variables like topographical variables, and we saw that the mid-camp was also the best, but not at 1 day, but at the 5 years satellite data. So we understand that our site comprises of both wet meadow and sagebrush. So we went for that to divide our, just to estimate, this index is best predictive in sagebrush or wet meadows. So you can see that for this, we have a 60 sampling point here in sagebrush, and 31 was in Rope Creek. So what we did for individual indices, NDVI was best in predicting soil organic carbon in sagebrush with the highest R-square value and low RMAE and low MAE value. But however, when we combine these indices together, we saw that Rope Creek was the highest with more R-square value and low RMSE value and MAE value. So what was our conclusion? The MISGAM was actually the best model in predicting soil organic matter at all the various post-stational years, 5, 3, and 1 day. Also, we saw that when we included other variables like aspect and slope, we saw it gave us like the best fitted model when comparing with modeling with just remote sensing alone. And we also discovered that the modeling method has a great influence on the predictive accuracy of soil organic carbon. So what was our limitation in our research? Firstly, we understand that climate variables have a very great impact on soil organic carbon, but due to the possibility like closeness of our sites, we could not get more of the MAE, or rather that's a mean annual temperature or the mean annual precipitation to include in our analysis. Also, the Sentinel-2B data that we have just has just 4 major bands, which are the blue, green, red, and near-infrared red. And so this limited the kind of indices we could actually use in estimating for soil organic carbon. So what are the further steps? Firstly, we want to further evaluate what is the variability of soil organic carbon within a 10-meter sampling pixel. And also, we also want to see how we can include more data to actually validate our model, and also see how we can apply our predictive model to other investor sites. And okay, our stakeholders and our funding agency. This project was actually funded by the US NSF and also the BLM, Western, Elite Grant, Upper Guernsey, and Southwestern University. And I just want to give an acknowledgement to Dr. Jenny, Dr. Micah, and the Elephant family for their support, and Dr. Anna for giving me the idea of using the GAM method, and I'm really grateful. Thank you.
We have a couple minutes for questions for Etinosa, so please submit those. The first one that we have for you is, how does your experience doing this research inform the type of work you would like to do in your PhD program and career?
All right, so it's really interesting in the sense that there's not much study that has been done in remote sensing and seeing how we can do more spatial correlation with soil organic carbon in a lot of ecological resource sites. And so I tend to see how I can further apply remote sensing to actually understand the net carbon emission within various restoration sites, around the country, around the world.
Awesome. Other questions? Otherwise, I might have one. What I would expect in sagebrush wet meadows is that the ones that hold water longer would be able to store more carbon because the slower decomposition rate from the water. Is that something you've considered using in your models?
So what I intend to do, if you check, trying to do compare between sagebrush and wet meadows, it was based in predicting organic carbon, but however, we had limited observation, and so we are thinking of getting more data, more wet meadow data to see how far can this actually predict, and so that is what we are doing in our other site, which is the Rope Creek, and just to see how we can incorporate more wet meadow data to see what best predictive model do we have.
Great. Thank you so much.
Thank you.
All right, let's give a round of applause and move on to our next presenter.
All right. Hello, everybody. My name is Katrina Stanek, and my project is titled An Organization of Policy to Inform Wetland Mitigation Banking Best Practices in Nebraska. It's quite a mouthful. I was able to accomplish this project through my community sponsor agency, the U.S. Army Corps of Engineers Omaha District Regulatory Branch, and my community sponsor, Jeremy Groff, who is the Nebraska Section Chief. So you may be thinking, well, what is regulatory and what does the Corps necessarily do in terms of like environmental work? So the Corps has regulatory authority under Section 10 of the Rivers and Harbors Act, and it also has delegated authority from the EPA under Section 404 of the Clean Water Act. And Section 404 authority is regulating the placement of discharged or fill material into wetlands or waters of the US. And so you may be thinking, well, what is fill material? A good example here is it looks like there's some soil maybe placed in wetlands. So soil and other sort of organic material can be considered fill, but we also consider non-organic material like crushed rock, concrete, maybe some construction materials also to be filled. So under Section 404, the Corps requires compensatory mitigation for larger impacts to aquatic resources. And this requirement is fulfilled in two ways that the Corps finds acceptable. One of those ways is permittee responsible mitigation, where the permittee or the impactor of the wetlands or other aquatic resources actually takes on the responsibility to restore, preserve, establish, or enhance an aquatic resource either on the construction site or off-site. But my project will focus on the second type of compensatory mitigation, which is third-party compensatory mitigation, where a sponsor or like a separate third party actually assumes that responsibility and has already restored, preserved, established, or enhanced an aquatic resource off-site. So my project focuses on a type of third-party compensatory mitigation called a wetland mitigation bank. And you may think, oh, that's kind of a confusing term. It's very like broad and all-encompassing. By definition, a wetland mitigation bank is a large wetland complex where resources are restored, established, enhanced, or preserved in order to provide compensatory mitigation for impacts authorized by the Corps of Engineers. So mitigation banks are actually the preferred method of compensatory mitigation by the Corps of Engineers. And this is for a multitude of reasons, but specifically wetland mitigation banks are, because they're such large wetlands, they're inherently more functional and they provide a greater expansive area for wildlife to take refuge in, endangered species, and also migratory birds to take refuge in. But one of the most important reasons why the Corps prefers mitigation banks is that they undergo a pretty extensive process where the Corps reviews a bunch of documentation for these banks, and they also go through a public scoping period as well as review by an interagency review team. So an interagency review team is defined as a group of state, federal, and local resource agencies that will review the documentation for a developing mitigation bank and provide input to the Corps about the implementation and management of the site. In Nebraska, the interagency review team is comprised of Nebraska Game and Parks Commission, Nebraska Department of Environment and Energy, U.S. Fish and Wildlife Service, U.S. Environmental Protection Agency, and U.S. Department of Transportation Federal Highway Administration. For my project, I also broadened the scope of our stakeholders to include Nebraska's natural resource districts, citizens of Nebraska, the Corps of Engineers, and Western Colorado University. So in August of 2023, the Nebraska Regulatory Office lost about 24 years of institutional knowledge regarding compensatory mitigation. And as you can probably assume, it was a pretty massive setback, and we had a lot of gaps in our program knowledge. And when a senior project manager with differing experience actually stepped up to assume the role, we found it was really hard to sort of hit the ground running and maintain the efficiency of our mitigation program. So the goals of my project set out to increase sustainable knowledge management mechanisms, increase stakeholder involvement and knowledge of the mitigation program, and also to maintain or possibly increase the creation of new mitigation banks. So my project is presented in 3 different phases. Phase 1 is project planning, phase 2 is development of materials, and phase 3 is the actual implementation of my deliverables. So to start with project planning, this started in about the summer of 2023. And during this time, I met with my community sponsor, the new mitigation chair, as well as the Omaha District Mitigation Coordinator to sort of take an inventory of the institutional knowledge that the Corps had about compensatory mitigation, as well as I also interviewed members of my office who maybe were not taking on the role of the mitigation chair, but may have some more experience with mitigation, and also inventoried the institutional knowledge that lied within them as well. And from this sort of scoping period, I created a list of resources or a list of needs, sorry, that directly influence the deliverables that I created for my project. So that brings us to the development of the materials or the deliverables for my project. There's quite a few here. But I started by creating a website sort of document for future posting to our website in order to increase our stakeholder involvement and knowledge of the mitigation program. And these documents covered essentially 3 topics. One was just the general mitigation program of the Corps. One was a document sort of describing permittee responsible mitigation and, the needs for that the impactor or the permittee would need to submit to us in order to make an acceptable site. And then the last was a document describing third-party compensatory mitigation and the development process for these mitigation banks. So next, I set out to tackle the lack of institutional knowledge and create an efficient knowledge management mechanism for my office. And this manifested itself in 4 instrument development fact sheets. And you may be thinking, oh, instrument, that's a new word. What does that mean? So an instrument is the legal document that is essentially like the culmination of the Corps' responsibility when developing these mitigation banks. This document details everything that should be known about the mitigation bank, like how big it is, what kind of resources it should be providing, credit release schedules, and service area for the bank. So I created 4 of these fact sheets, one for each phase of development the banks go through. And this is more of just like a streamlined sort of quick glance for the project managers to know if they're on track, what their next steps should be, and how they should report their milestones in our administrative record. Next, I created 2 instrument modification fact sheets. And the first one I created is what we call a substantive modification or a G1 modification. And this is a modification to an already established instrument that would drastically change what was written in the first legal document. So this sort of modification would need to go back out on public notice and enter a public scoping period again. And then I also created a second instrument modification fact sheet for what we call streamlined or G2 modifications. And these are for simple modifications to the instrument, like processing a credit release or a simple change in some language in the instrument. Finally, for this part of my goals, I created an IRT or interagency review team fact sheet. And this is for the project manager to really understand the IRT's role in developing the mitigation banks. It includes who is included in the interagency review team, their role in development, like what they should review, and also when and how to contact the interagency review team. Finally, or not finally, almost finally, I created 2 milestone trackers for project managers to use in order to increase their efficiency when developing these banks. The first one is more of a managerial teams list, and this lists every single bank in Nebraska that's in active development right now, as well as what phase of development it's in and who it is assigned to or what project manager is responsible for it. And this is perfect for managers to take a quick glance to see, you know, what's moving in Nebraska and who holds most of the responsibility. And then down here is a instrument milestone tracker. And this is an Excel sheet for project managers to use for specific banks. And this mainly is supposed to track how many days each milestone takes, sort of right here. And this is for project managers to input into our administrative record for upward reporting to our headquarters, just to, you know, make sure everything's moving smoothly. And finally, I created 6 correspondence templates. This is in the form of a public notice, some official letters, and also some email templates for project managers to use when corresponding with the public, the interagency review team, and the sponsor. So that brings us to the final phase of my project, which is the implementation phase. Currently, we're still sort of in this phase. I feel like this phase is going to be moving for quite a while, hence the project is not in here. As of right now, all of my deliverables are undergoing review by my community sponsor. Most of them have been reviewed and turned back to me. And as I am receiving these finalized documents, I am putting them into our share drive under our mitigation folder and organizing that to, again, increase the efficiency of project managers. So it's an easy place for them to know exactly where to find what information they need quickly. And then also the website posting is anticipated to be updated by September. So if you want, you can, or by summer, sorry. So if you want, you can check it out. I will give you guys the link if you're interested. And this is going to be more of a lengthy process just because when you post something on the website of a federal government page, it has to go through like a lengthy review process by our public affairs. So it's moving, but hopefully it moves pretty quickly. And with that, I would like to say thank you to everyone who made this project possible. I would like to start with my faculty mentor, Dr. Hannah Carroll. Thank you so much for all of your support, your editing skills, and for just being a rock for me through this full experience. I really appreciate it. And then I would also like to thank my community sponsor, Jeremy Groff. All right, he's right here. Thanks, Jeremy. And thank you again for just always being available to me, for providing amazing expertise, like limitless knowledge. It feels like crazy. And for also being timely in your reviews. It really makes a difference. I would also like to thank Angela Kaup and Lauren Eulig, my coworkers, for standing by me and navigating this massive undertaking by my side. It's been amazing to have you guys to bounce ideas off of. And finally, from the core, I would like to thank Karen Lawrence, the Omaha District Mitigation Coordinator, for again, always being available and providing a bunch of knowledge and expertise when it comes to mitigation. I would also like to thank my friends and my family for supporting me through grad school. It's not an easy task, and I thank them for putting up with me and helping, you know, again, be my rock throughout this whole experience. I'm very proud to represent everyone I mentioned with this work, and with that, I will take questions.
Awesome. So our first question for you is, does the Corps solely authorize management on its own lands and or does its authority supersede that of other federal land management agencies?
That's a good question. So the Corps' authority actually covers like all of America. We do projects on, or we permit projects on private lands, federal lands, public lands. It's more of like a Clean Water Act sort of overarching theme. So yeah, we don't necessarily supersede jurisdiction when it comes to other federal agencies. Specifically, like, I don't have a lot of experience with how the Corps works with the BLM, but typically we would sort of work in collaboration with those agencies instead of taking, immediate control of a project.
A related question, will these mitigation practices apply to private land or only public lands?
All of the above, private, public, and federal. It just depends on who is the sponsor developing the bank.
And one last question for you. Are most mitigation banks in Nebraska being developed by out-of-state financial investors and consultants or by local and regional experts in restoration?
That's another good question. So as I've started to immerse myself more in the mitigation world, we've actually seen an uptick of out-of-state investors and land managers actually becoming interested in mitigation, especially third-party mitigation. But as of right now, most of the active banks we have are from our Department of Transportation, as well as some like private sand and gravel companies that operate in Nebraska.
Thank you so much. Another round of applause. Great job. And we'll move to our next presenter.
All right. Hey, everybody. Thanks for being here today. My name is Katie Young, and for my MEM project, I worked with the Mountain Studies Institute in Silverton, Colorado, on GIS analyses prioritizing restoration and preservation in the headwaters of the Animas River. As just kind of an overview of what I'm going to talk about today, I'll start going over background information to give some context as to why this project is important. I'll then go through some definitions defining what is a weighted multiple criteria analysis. I'll go through my methods, share some results with you all, and then talk through next steps. So as I said, my community sponsor was the Mountain Studies Institute. They're based out of Silverton, Colorado, in the southwestern portion of the state. They are an environmental nonprofit that focuses on using scientific research and education to build resilience in mountain communities. This is a map of San Juan County. You can see where it is there in southwestern Colorado. It's kind of nested in the San Juan Mountains. The boundary of the county it follows mountain ranges that kind of delineate the watershed basin for the headwaters of the Animas River, which is this line kind of going from north to south through the county. The Animas River is an important river. There are a lot of downstream users, and it's a major tributary to the San Juan River and ultimately the Colorado. So historically, the economy in San Juan County was based around a very productive mining industry, which started in the 1870s and extended until the 1990s. This industry led to a lot of environmental and water degradation in the watershed. And to date, most of the restoration activities in this area have focused on mine reclamation. Fast forward to current day, the economy of the area is largely based on outdoor recreation and tourism, which comes with its own set of ecological challenges. More people recreating in the watershed leads to increased sedimentation in waterways from trail erosion, road erosion, things like that. You also have increased instances of human waste in the watershed, increased disturbance to wildlife, a lot of things that end up affecting overall water quality and watershed health. We're kind of in a unique political climate right now where a lot of federal money has been set aside recently for addressing watershed restoration issues such as these. This funding has been set aside through the Bipartisan Infrastructure Law and the Inflation Reduction Act. So in response to this kind of intersection of identifying issues in the watershed and a surge of federal funding, the Mountain Studies Institute, the town of Silverton, and San Juan County have all kind of identified now as a really good time to start working on a countywide prioritization, identifying areas that are really well suited for restoration activities and preservation of important ecological function in the watershed while maintaining a robust recreation economy. So, in response to the identification of this intersection, those three entities, MSI, the town of Silverton, San Juan County, convened the Animas Headwaters Ecological Action Division, or the AHEAD Collaborative. This is a group of around 30 stakeholders from a lot of different backgrounds, including federal agencies, state and local agencies, nonprofit organizations, recreation industry professionals, environmental consultants, and scientists, who all got together to brainstorm the best way to go about prioritizing preservation, restoration, and recreation in San Juan County. They all worked together to define the objective of identifying areas within San Juan County, the headwaters of the Animas River, that are best suited for those three things. And they kind of identified that the first place to start in this is a GIS analysis, a desktop analysis, to identify those areas. So that's where I came in. I was introduced to the Mountain Studies Institute by my mentor at the time, Garrett Smith. He had connections with the Mountain Studies Institute, and I began talking with Jake Kurzweil, who works for Mountain Studies Institute. We decided that the best way to approach this prioritization analysis is through the use of a weighted multiple criteria analysis. We needed to come up with definitions of what we wanted preservation and restoration to look like in order to do that. And so we agreed on these definitions here. So what is weighted multiple criteria analysis? This is the process of identifying and kind of assigning significance to different data layers in achieving management goals. All of these ranked data are then brought into the GIS and combined to create a map that visualizes areas of high priority for restoration and preservation. So our first step was ranking all of the different data that we were going to be incorporating into our analysis. The AHEAD Collaborative group identified around 40 different categories that we deemed important to include for preservation and restoration. These included a wide variety of things like wilderness boundaries, wetland locations, wildlife habitat for species of critical conservation concern, weeds, human infrastructure, a whole variety of different categories. We then went to the scientific literature and did a large literature review to determine the significance of each of these different categories for restoration and preservation. We had a 1 through 5 ranking system. Things with a value of 5 had high significance for preservation or restoration. Things with a value of 1 had no significance. Things that tended to have significance for preservation were intact ecosystems, critical habitat, and remote areas, so regions of the county that were far away from roads or trails. And things that had low significance for preservation were heavily impacted ecosystems or areas that were near infrastructure. The opposite tended to be true for our restoration rankings, with impacted ecosystems and areas near infrastructure having high restoration value. These areas benefit from restoration activities as well as have great access for equipment and people to get into these areas to implement restoration. And then intact ecosystems in remote areas are less significant for restoration activities. So after we ranked all 40 of these data sets, we then had to go into GIS and find a way to visualize them. All of the different categories are kind of combined into one, or I guess first we had to convert all of our data from categorical data to numeric data based on those rankings. So here's an example where we had a data set on watershed condition. We had properly functioning watersheds and functional at-risk watersheds. For preservation, properly functioning watersheds were given a ranking of 5, while functional at-risk watersheds were given a ranking of 3. So on this side, you can see that they have then been converted to a numerical value corresponding to their ranking. So we then had to combine these rankings for all of the different categories that we used in our analysis. This is a picture of the model that I built in ArcGIS Pro for this process and kind of illustrates all the different tools that we used within the program. And so the idea here is that, we have this watersheds layer where we have, a ranking of 5 for functioning watersheds. Maybe we have fen wetlands that also have a ranking of 5. The overlap of those areas will then have a value of 10 in our final analysis. And so we have a visualization of high values and low values for each of these management goals. These are our initial results for both the preservation and the restoration analysis. Areas that are dark green have high significance, and areas that are red have low significance. Some important areas that stood out. For the preservation analysis, we have the Rico Mountains, Molus Lakes, and the Needles Mountains that all ended up being high priority. A trend among these different regions was that we had a lot of overlap of significant wildlife habitat in the southwestern portion of the county. And then also these areas tended to be pretty far away from roads and trails. This Needle Mountains area in particular was very far away from human infrastructure. Our restoration results you can see are quite different. We have the Animas Forks area, Mineral and South Mineral Creek, and then the Molus Lakes area that were all pulled out as high priority. Trends among these regions appear to be areas with a lot of wetlands and beaver habitat that are in close proximity to roads and trails. So there were a few constraints of our analyses. The first being that our wildlife data were not very well honed. We had really broad polygons that were not showing very specific areas for wildlife habitat. And so that kind of led to some of these really stark lines that you can see, especially in the preservation analysis. Colorado Parks and Wildlife is currently working on a habitat sensitivity analysis that we were hoping to be able to incorporate, but it didn't get together in time. But once it is available, it will be really easy to plug into those models that I made and kind of give a more accurate inclusion of wildlife habitat in these analyses. Another constraint is just a lack of data. So you can see that on the western side, or on the eastern side of the county, for both prioritization analyses, we had a lot of red. That might not necessarily be because these areas are low priority. It could be because they're very remote areas without a lot of data available. They're wilderness areas where maybe we just don't have as much information as we would like. And then lastly, these are intended to be used as a broad overview of areas to start digging deeper to look for restoration opportunities. So next steps for the project. These maps have been shared with the AHEAD Collaborative Group 2 weeks ago. We had a big meeting where we got everybody together, shared our results. We're in the process of collecting feedback right now that will then be incorporated into a final report. We're then going to build a community report that will be made available for anybody in the county or downstream who wants to look for opportunities to develop restoration or recreation opportunities in the area. My other recommendations are for MSI to create an outline of the process of applying for bill and IRA funding. These funding sources are notoriously very difficult to navigate. And so since this report is intended to be a resource for people looking to implement these projects, also giving them resources to apply for funding would be extremely helpful. Next steps for me. I was just hired by Montana Trout Unlimited in my hometown of Red Lodge, Montana, and have started working on kind of developing restoration programs in my home watershed, the Beartooth Mountains. And with that, I would like to say thank you to Jake Kurzweil and Julia Ledford at the Mountain Studies Institute. Jake was my community sponsor, and Julia helped with a lot of the heavy lifting for this project. Thanks to Garrett Smith, my mentor for my first year, who continued to provide a lot of really awesome GIS support even after he's since moved on to Arizona. Thanks to Micah Russell, my mentor, for all the guidance this year. It's been greatly appreciated. Thanks to all of the AHEAD collaborative members for their input, and then the Haley family and the Mountain Studies Institute for providing funding for this project. Thank you.
Okay, now it turned on. Okay, so a few questions for you. How long has the AHEAD group been active, and how successful has the group been in finding consensus in what to prioritize?
So the group just started in February of 2023. So it's still a really new group. It really has not been that difficult to find consensus on a lot of these issues and what to prioritize. I think that we might see a little bit more of that dissent, or not dissent necessarily, but more like debate as to what exactly is the highest priority with this feedback from our initial analyses.
How often did the model builder ArcGIS software crash while compiling all of your data?
Maybe I've blacked that out with all of the rage and head scratching. No, it wasn't as bad as I anticipated. It did take a really long time for those models to run, but I think I only had things crash like once or twice.
When an area is both a high priority for restoration and preservation, how do you decide which direction, preservation or restoration? For example, Mullis Lakes.
That's a really good question. I think it would be on a case-by-case area. So you could see those green spots were pretty broad. And so that's sort of where it's identified for both of these things. So it takes some ground truthing to go and investigate the area, see maybe here we have a lot of trail erosion happening close to a waterway. And so that might be a restoration project area. Or we show up on the ground and it's like, oh, this is a beautiful, pristine wetland. We don't need to do any restoration here.
Great, thank you. Let's give Katie another round of applause.
Hello. Thank you all for hanging in there with us. I know after lunch, I usually need a nap, so appreciate it. My name is Destan Gerhard, and the project I've been working on over the past year and a half has been the nexus of wetland restoration and agriculture. I'd like to start off by doing a land acknowledgement. My project has taken place just outside the town of Gunnison, and these are the homelands of the Ute Mountain Ute people, who are the Weminuche band of the Ute Nation. And to find out more about the indigenous people and their homelands, as well as the current existing communities, you can visit native-land.ca. All right, so to begin with, my project has been the initiation of a 3-year study out at the Cold Harbor Ranch, located about 15 miles outside the town of Gunnison. And I did the baseline data collection last summer, as well as the study framework design and data analysis, as well as BDA installation out there. And at the end of the 3-year study, we hope to get our research published and understand better about the connection between low-tech process-based restoration methods, as well as cattle grazing and that form of agriculture. So you might be asking, where is this at? I just mentioned Cold Harbor Institute. You can see the town of Gunnison here, and then this polygon, red polygon, is the Cold Harbor's 343-acre ranch land. Within their ranch in the lower photo, you can see that the study site is taking place in their eastern pasture, which has a couple unique characteristics, being that it's bordered by Highway US 50 to the north and Colorado Highway 114 to the east. In addition to that, the southern part of the study site is a lowland wetland area that gradually moves into a sagebrush, drier upland area. All right, so an important question whenever doing a research study is why? Why are we doing this? Well, namely, this has been the culmination of the work of 3 previous MEM students, starting with Catherine Bickley. She did a 3-phase restoration proposal for Cold Harbor Institute and their entire property, which then led to my predecessors, Brendan Bloyd and Savannah Adkins, doing the permitting as well as planning and the data collection framework for the installation of the low-tech process-based restoration methods that we put out there. Next, this project perfectly aligns with the goals of Cold Harbor and what they want to do and what they allow for out at their property. They currently have an NRCS wetland easement on their property, which restricts access to the property for a given period of time, so that it allows for an undisturbed environment for migratory waterfowl, as this is a big passage for them. In addition to that, they allow cattle grazing out on the property from a local business owner, and they also are partnered with the MEM program here at Western and are very heavily invested and allow for all kinds of scientific research to take place out there. And if you haven't noticed through everything that I've said, very interested in wetland preservation and restoration in general. So lastly, BDAs. This is the low-tech process-based wetland restoration method that we used out there. BDA stands for Beaver Dam Analog. And as you can see in the picture over here, it's kind of like a little crappy human-made beaver dam. And not so beautiful words. Why do we choose BDAs? They are a newer burgeoning form of the LT PBRs. And there isn't a lot of research out there about the connection between wetland preservation and cattle grazing, mainly just how BDAs can be used to prevent stream bank erosion. And on top of that, there are beavers currently out at the property, and we've seen, like in restoration efforts out in the Taylor Park area, that when there's beavers present in the area, sometimes they might come in and mess up your BDAs, but make a larger beaver dam complex. And so that'll be interesting to see if that happens out there as well too. And then the most important part about why we use BDAs was no impact to water rights. Water rights are very important, and we are not pooling any kind of water or storing water on the property. We are merely slowing water as it moves through a water channel out on the property, and slowing and spreading it out into a riparian hay meadow. So no one's water rights are being impacted, and that is very important to establish. All right, so to get a better understanding of the regional kind of geographic context of the watershed that leads into the study site, you can look here at this 3D generated model of the Tomichi Creek watershed. To orient yourself with this, there's Monarch Pass going up over the Continental Divide here. And then down here, this is Highway 50 that comes through here. And Gunnison's about 15 miles this way. The Tomichi Creek watershed, the drainage basin is just over 1,000 square miles. And as you can see in this photo here, the brown representing high peaks and the green representing the lowland areas. This is a very tight and intimate mountain valley section that allows for a really lush and verdant valley floor where there's a lot of wetlands and a really, really dynamic riparian area. And then to look a little bit deeper, we've got the Tomichi Creek that runs along the valley floor here, and the Cochetope Creek, which starts up in the Cochetope Hills and runs down through Cochetope Canyon and meets right at our study site location. So these Cochetope Creek is a part of the Tomichi Creek watershed. However, these are the 2 largest by land size, and Cold Harbor has the unique distinction that these 2 waterways meet on their property, and specifically right in the eastern pasture. Now, this is an overhead view of the 3D model that I just showed you. So you can just kind of get a better sense of all the different rivers that lead into these 2 watersheds. And they both are defined by having a HUC code of HUC 8 for Tamaichi Creek and HUC 10, and HUC standing for Hydrologic Unit Code, which is the USGS's classification system for all waterways and rivers in the United States. The lower the number, the bigger the drainage basin is for that river. And then now we just take a little bit of a deeper dive into the watersheds, and you can see the scale of all the minor watersheds that lead into this. It's a total of 14 of them. So a lot of water draining into this area, really, really great wetlands that exist out there. And there's a big need to figure out how to balance agriculture, cattle grazing specifically, and wetland restoration and preservation. So the study sites. To the north here, you can see this is our research plot, and to the south is the control plot. Along the middle, we've got the tailwater ditch where we installed the 10 BDAs at the end of the season. And then right here in between the two research plots is a historic railroad grade, which essentially is a 3 to 4 foot earthen barrier that creates a really nice delineation between our control and research plots, allowing for no migration of surface water to come over from one to the other. The study site tailwater ditch is unmaintained, so we don't have, it's not a part of the ditch system that irrigates the entire property, so we don't have to worry about going out there and maintaining these ditches. It's really key to this, as well as there's annual water flow that comes from this culvert. The neighboring landowner, when they take their water right every year, it always ends up that they have an excess water that flows onto Gold Harbor's property under Highway 114, and annually floods this ditch with the dark blue ditch with water. There additionally are these other supplemental tailwater ditches that have been created over time, and with the BDAs being installed along here, that provide a great opportunity for water to get pushed further up into this more upland, drier area. And the study site's perfectly imperfect too. Can't do anything better than this out there in nature. All right, so now we're going to look at some graphs and maps. Because I just did baseline data collection, there's no real conclusions that can be drawn from the data that was collected out there. However, there are some points of interest to kind of note and will definitely be looked at over the next 3 years. Just to orient yourself here, this graph on the left perfectly matches up with these soil moisture points here on the right. So if you think about the earthen barrier would be, right through here. And then these are all the moisture points in the research plot. This is looking at your volumetric water content, which is basically just your soil moisture compared to the median temperature. As we can see, all these points are, relatively the same size. So there isn't much variation in the soil temperature, which is to be expected in a riparian hay meadow. But we can see here that along in the control area that we have a lot more darker colors. So we're seeing a lot more soil moisture down here as compared to up here. And these are the median volumetric water content. So we tried to correct for any kind of outliers that may have been present. Now, looking at the second point of data that's being collected out there is the vegetation data. I set up these 6 transects, and just to start off again, these points are also GPS correlated with these points over here. You can see here that we're looking at the size of the circle indicates the number of native plants, because that's going to be interesting to understand of whether or not we're somehow impacting the spread of non-native and invasive species out there. And so that you can see here that most of these points are, pretty big. So we've got a lot of native species out there. And this graph looks at the number of individual plants that were identified at each spot. At each spot, I didn't count the total number of plants there, just the individual unique species. And then the one of the more important parts of this vegetation data collection is going to be understanding the increase or decrease in wetlands. And how we're going to understand that is the amount of wetland obligate plants. That's going to be our threshold for understanding whether or not the wetland area is increasing or decreasing over time. As you can see here, it's very interesting to note that our control plot, though closer to Michi Creek, this river down here, it doesn't have a lot of wetland obligate plants. The lighter, more orange color indicating fewer wetland obligate plants, whereas our control plot up here has a lot more wetland obligate plants. And that just might be a fact of the fact that last year was a really high snowpack year for the Gunnison Valley. And so this control or the research plot got inundated with water and stayed that way for a very long period of time. Now, the third point of data collection is the overhead drone monitoring that we're doing to look at land cover change over the life of the study. We went out there three times last year, once in May, July, and September to do a drone flight mission. And then in ArcGIS Pro, I did a vegetation index analysis. And so what you're looking at here in each map, the darker, more purple areas are the areas that have a lot more green in them, indicating dense vegetation. And then the lighter yellow and orangish areas indicate drier or the less green areas. So in May, basically what you're looking at is a lot of dead plants. And then in September, which is post cattle grazing, what you're looking at is a lot more bare ground. And some interesting things to note here that we're going to look at over the next 3 years is in May, this spot here is very green. So it's experiencing a lot of vegetation growth pretty early on. However, down here, when we look at it in September, it's starting to lose its vegetation density and looking a lot less green. And this is where it lines up kind of perfectly with where our last BDA is installed. So it'll be interesting to see if that area maintains this pattern over the next 3 years. And with that, I'd like to acknowledge all the people that have helped me along the way. This has been incredible. Thank you, Dr. Hannah Carroll, my academic mentor. Jesse Baker, if you're listening, you were my first one, and I appreciate you led me down this path. Dr. Phil Crossley for all the GIS and drone monitoring, Kate Clark, Danny Laird for plant identification help, Brendan Bloyd, Savannah Adkins, Madeline Vanderkirk, Jillian Bauer, and Nate Gore. Without you guys and your volunteers that came out and helped me, never would have got those BDAs installed. I do not think I would have been able to do that on my own. And then most importantly, Cold Harbor Institute, Western Colorado University, Haley Family Fund for all the funding for this project, and our public lands partnerships with CPW, U.S. Fish and Wildlife, Trout Unlimited, and the NRCS. Thank you very much.
All right, thanks, Destin. So one question for you. Seeing as BDAs don't interfere with water rights, do you foresee BDAs being utilized by more landowners in the region?
I'd say so. I'd also like to add the distinction that you could potentially be impacting water rights with BDAs if used in a different context where you're attempting to store or pool water. Those are two words that are like, if you're doing either of those things, it's not good. So the fact that we use them in a very specific context allowed for no impact on water rights. However, to answer the question specifically, that's kind of what we're going for here, is to be able to understand how BDAs could be used potentially more effectively than standard irrigation methods with like, the flood irrigation using piping. Maybe you could use BDAs instead in certain contexts. So yeah, definitely, hopefully.
All right. If there are no more questions, then I will transition into group questions. So please take a moment to consider and submit those to the QR code for our panel. Yes, a question to start with, Etinosa, another one came in for you. As metrics, including NDVI, are very relevant to vegetation, would you incorporate other topographic or hydrologic models in looking at wetlands or riparian areas?
Yes, but however, based on our study, we decided to use like a US national map, which is as a 10 meter resolution. And so we wanted to maintain that consistency since we are using the NDVI for the StatNet2 having a 10 meter resolution. And so that actually constrained how we're able to do a lot of analysis of other topographical variable. So I guess for now we are just focusing on using focused on the 10 meter resolution. But if we want to expand more, I guess we can also include it.
Thank you.
Thank you.
So if you all had to think about what you've learned through all of these group interactions and how the research that you've done, the work that you've done overlaps, what kind of collaboration would you look for if you could do it all again? Or like what would you recommend to first year students who are just starting out on this type of journey?
I can start. So I had the opportunity to work with a federal agency, which when I was a first year student, that seemed very scary and like unapproachable to me. And just through my employment and interactions with other federal agencies, I've learned that especially, in the biology ecology realm, a lot of the employees of federal agencies are very, very excited to help students and to share their knowledge with students. So definitely reach out. Everybody's busy, but not busy enough to not give you the time of day.
I would say also don't be afraid to allow your expectations of your project to change as it starts unfolding. My initial deliverables were much further reaching than what I was able to accomplish, but I still was able to get some really cool things done. We just had some hiccups along the way that were unanticipated, and I think that almost everybody can count on that happening. And so just being flexible and being willing to roll with the punches a little bit.
I'd say for myself, the most important thing was just talking to people. The only reason I hopped onto this project was because Brennan Bloyd, my predecessor, when I first moved to the Valley, I met him at the gym and he was like, "Hey, you're MEM, I'm MEM. Do you want to come with me out to Cold Harbor?" And he was just walking around out there and we walked up like the bank of Tamichi Creek and I was like, "This is beautiful. How do I do this?" And then I just kind of kept nagging him along the way. And eventually it was like, "Hey, man, you can take this over if you want." I was like, "Okay, awesome." So, and even along with that, I had mentioned him and Savannah Adkins. Like Savannah didn't quite have a project figured out, but Brennan had a lot on his hands with his project. And so she was able to come in and kind of like fill a need for this like larger project as well too. So if you know anyone that has a really well-defined, but like probably overwhelming project, you could probably partner with them and then be able to break it up into more manageable pieces so you guys can like actually get some good work done.
All right. For me, I would say meeting expert in your field, and for my project, I had to meet Dr. Philip Anna, and just to inquire about my project because none has been done. It will amaze that there are just 4 publications on wetland and soil carbon and remote sensing. And so it was quite difficult for me to, see what has been done in, the wetland and mostly the sagebrush. So talking with a lot of mentors to bring ideas together and brainstorm was what really helped me, come to this point and try new things. So, like the mist gum was something that has not really been tried. And so we're like, okay, let's see how this, nonlinear machine learning, works and actually give us the best model. So, yeah.
All right. Thanks all for your wisdom. You all have done really well. Here's another question from the crowd. Do you think changes in the water cycle, like increased swings between drought and wet years, will impact watersheds moving forward?
I can start. I think it's inevitable. I think that's a definite yes. You know, climate change, we have seen a lot of impacts to aquatic resources. And I think specifically wetlands are really, really important when it comes to changes in the water cycle because they are the storage unit for our water. They filter our water, and they're a really integral part for, like I mentioned in my project, wildlife and migratory species as well. So I think it's really important that as we see these changes of climate change, you know, sort of progress and ramp up, that we spend a lot of time focusing on wetlands and maintaining their functionality.
Yeah, completely agree. And low-tech process-based wetland restoration methods, like BDAs, one that I used in my project, are like that. Those are the things that people are using because we can't just like necessarily treat waterways as like pipes or like channels that water move through and then that's it. They're just traveling from point A to point B through this river bed. There's a lot more happening there, and wetlands right along the edges. It's like such a dynamic environment, and being able to slow water as it moves through them and preserve these wetlands for reasons like Katrina said, it's just so vital. Like especially in drier years when there's less water moving through, to be able to preserve these wetlands and help them like, you know, be sustainable it's huge. It's just huge.
Yeah, I don't have a whole lot to add. Those are both really great explanations of the process. We can definitely count on climate change affecting wetlands and watersheds. But identifying areas where things are in good shape and making sure that we don't degrade those areas is really important. And then, yeah, looking for restoration opportunities so that we can preserve these things as best as we can moving into the future, creating these, you know, sponges to hold onto water so that when we have a lot of precipitation, it can really soak into the ground and hopefully help get us through drought periods is going to be important.
All right. Katie, while you have the mic, what are the attitudes and concerns of recreation-oriented stakeholders towards preservation and restoration in the watershed?
What are recreation industry people saying about it, or?
Yeah.
Okay. They definitely were a little bit less outspoken as members of the AHEAD group. But I think that they all agree that, you know, their industries depend on maintaining the beauty of these places and maintaining, you know, the ecological function of these places. Like, you know, in 2015, a lot of people may be familiar with the Gold King mine spill that happened outside of Silverton. And although, you know, issues with water quality remaining or relating to mining are super prevalent in this area, this was the first time that it was really apparent. Like the Animas River was running orange. And that year, the region really suffered because people were really freaked out by the river being orange. Tourists weren't coming to town. They weren't coming to recreate in this area, and it had a really significant impact on the economy. So I think the recreation industry at large is really behind a lot of these activities to preserve this area for their line of work as well.
All right. And one last question. The audience is very curious. They know that you're moving on to Montana Trout Unlimited, but what about the rest of the panelists? What are your next steps?
Currently still unemployed, so any job opportunities, hit me up.
Currently, I'm working full-time with the Corps of Engineers as a regulatory project manager, so be there for the foreseeable future.
Okay, for me, I going over to do my PhD at Old Dominion University, working with Dr. Taylor. I guess she's on Zoom now, and you know, yeah.
Awesome. Well, let's give these panelists another round of applause. Thank you all so much. We're moving into a 10-minute break. So please feel free to walk around and do what you need to do. And our next group will start at 2:40.